Hey, I'm Chase Cunningham, Dr. Zero Trust, if you want to call me that. But I think it's interesting to go through something that just came across the wire. You want to pay attention to this. And this is not meant to come across as, hey, there's an issue with a vendor or a particular technology, or whatever. This is something to be aware in the context of better cybersecurity and practices that you need to consider. So, this article came out recently. Malicious Microsoft signed Windows drivers wielded in cyber attacks. Wielding these types of things in old attacks, this is not really brand new, but the methodology that's being put together here and the way that the adversaries are using these trusted certificates to work their way up the chain of trust, if you want to call it that, the supply chain, if you want to call it that, is really interesting. So let me run through a couple things here to kind of wrap your head around what we're talking about. So Microsoft says it suspended several third-party developer accounts that submitted malicious Windows drivers for the IT giant to digitally sign so that the code could be used in cyber attacks. Okay, understand that. In tandem with Patch Tuesday, which was recently, the Tech Goliath also revoked certificates used to sign those bad drivers. So these are bad drivers that were signed by Microsoft. At Google owned Mandy and Sentinel-1 and Sophos told Microsoft in October that multiple cybercrime gangs were using malicious third-party developed Microsoft signed kernel mode hardware drivers to spread ransomware. Now, that's the thing to really go, well, wait a second, kernel mode, that's why would I care about kernel mode? And this is what you really should care about when you're thinking about the kernel mode side of that. So for the non-egghead types, this is what you should understand about kernel mode. So a malicious Windows kernel mode hardware driver, a lot of words there, with Microsoft stamp approval is unhindered from doing all kinds of things once running on a system, such as literally Hobble endpoint protection products, EDR, those things that you use to defend your endpoints. Uh, and thwart intrusion detection. Microsoft has required kernel mode drivers to be signed through the Windows hardware developer program since Windows 10. The issue that we're talking about here is that there was third parties that were using, let's call them, different ways of getting access to these signed certificates and pushing stuff out through this sort of program to get things onto a machine. And I'll show you how that works in a second. And then once it gets to the machine, because it's operating at the kernel level, which is deep into the operating system for the non-egghead types, it gives them all kinds of power to do things on a network. So imagine if you're running an endpoint protection product, EDR, some sort of EDR system, some sort of defender or whatever on your endpoint, and someone is able to get something to your machine that makes them, call it God mode on your box. If I'm God mode on your machine, what could I do? I can turn off software that you have running that would be used to defend your endpoint. And then I can do other things. After I do that, it's kind of Katie bar the door. Know that the real issue we're talking about here is that the endpoint protection, the EDR stuff, is being disabled with valid signed certificates from Microsoft's hardware sort of provider system way up in the chain of trust, the software supply chain, that could effectively turn off software security things that you have on your endpoint. This is actually from November 11, 2021, from Microsoft itself. And again, I'm not bashing Microsoft. I'm just saying this is the reality of the space. This is a year old. HTML smuggling surges. You're wondering what HTML smuggling is, and I'll tell you why that matters here in a second. Highly evasive loader technique increasingly used in banking malware targeted attacks. So basically, what's happening here, the attacker is able to smuggle an encoded malicious script within a crafted HTML attachment or web page. When a target user opens the HTML in their browser, so you go to a website, you open the browser decodes that malicious script that the bad guys put in there, which in turn assembles that malicious software payload and puts it onto your machine. All you have to do is visit the site. It's not going to be stopped because there's not an email click or whatever else. The malware itself is being pushed down to the machine, and then it's building based on the script the malware on the box. And then it has these malicious kernel things, drivers that we're talking about, that operate as kind of God mode on your machine. And now it's turning off the security control software that you have. And it can do pretty much whatever it wants. It could move into the network, it could escalate privileges, it could crack other things. It's a really bad place to be. So the question you should ask yourself is, if that's the thing, if this is going to slide by phishing protection, phishing training, and it's going to turn off my EDR solutions, how do I know when this occurs? Well, the single source of real truth in any information system ultimately is way down to the network. Sooner or later, all packets, all electrons are going to move back and forth across that apparatus, that network. If you have really good understanding, context, visibility, which is something we talk about in ZT from step 0 to all the way through, you will see anomalies occur. You will see strange things take place. When you see an aberration take place across network traffic, that's an indicator that you should go figure out what's going on. Again, this attack, these combined methodologies are meant to get past your primary means of defense, phishing, training, and EDR, endpoint protection programs. If they do that, where will you have an ability to respond? It's going to be at that network level. So my point to folks would be understand the context of these threats, understand the context of these risks, apply controls across that enterprise in a really intelligent fashion, focused on what the adversary is doing, which we're breaking down here, and then know where you're going to be able to pick up on those anomalies so that you can act. If you're ignoring the value that you can get from the visibility and from the context on those network assets, you're going to miss this, and it will potentially be a bad day. This is, you could say, very much like Eternal Blue 2.0, which if you've done any of the reading on Eternal Blue, that was the beginning of some of the most large ransomware infections in history. So be aware, understand, don't be afraid. Just be aware, understand what's going on, and know where you can apply controls, context, and the right technologies to solve this problem. Thanks very much. Hate to be the harbinger of bad news, I guess, but try and get out in front of things and help people do better.